Good morning, everyone. In the last session, we discussed about the collection related sections here. We'll identify today one of the another important section called map related section. So how these particular maps are going to work internally, and we'll try to discuss about the one by one how it is implemented internally here. Okay. First, we'll discuss about the interfaces. Later, we'll discuss about the classes section here. Observe carefully the first interface here. We are having map here. Okay, in the collection only I'm going to write. So collection txt file. In the collection txt file, I'm going to write this particular map related section. The first interface we are going to discuss the map, and map will contain key value pair. Okay, map will contain key value pair here. So inside this particular map, what are all the methods we are having? First we need to understand here. Now observe carefully. I'm closing to other tabs whatever we used so far here, and I will try to load this particular map here. This is the package we need to use, java.util, and it is coming from under the java.util package. Now if you see what we can understand here, now this is the one of the interface here. It is trying to introduce from the 1.2 onwards here. Now you can see size method. Okay, so size method, we don't need to discuss about this particular size method because we already familiar with this particular size method, how it is going to work. And is empty method, getting the point. So is empty also we identified internally how this particular is empty is going to work. And contains key. So here we need to understand the one of the important section. We'll try to identify contains key, and internally what we identified in the collection related section, we identified only contains here. Okay, but here what we are doing is contains key and contains value. So both we are going to check. Okay, both we are going to check. Getting the point. This is important. So contains key, whether this particular key, whatever the key we are going to provide, the key is available or not, we are going to check. And the same way, whatever this particular contains value we are going to provide, the value is available or not, we are going to discuss here. Okay, this is important information we need to understand here. After this, so get method we are having. Getting the point. Get method we are having. So what it will do? Now you can read this. Return the value to which is specified the key is mapped here. Now what I'm doing here, I'm trying to pass the key. So whenever this particular key is matched here internally, it will try to return the value. It will try to return this particular value. Okay. And after get key, so what is the method we are using? Put method. The put method internally, it is trying to take as a two parameters. First one is key, second one is value. So here we cannot use the add method because there is no relations here. If you observe carefully, this is the unique interface. This interface cannot extending or cannot implementing any another information. Getting the point. So this is the topmost interface we can discuss here, how we identify the particular collection interface. Same way, this particular interface we are having here. Now we'll understand here how it is going to work internally after this put method. And we can easily understand here, these are all the remove method. So remove method, whenever we are providing the key, it will satisfy the key. Once it is satisfied, it will remove the value. And here now you can see put all method. So whatever this particular add all method we identified, same way we are having put all method. Okay, so clear method. Clear method, we already familiar with this. Getting the point. So it will try to remove the all the object from this particular map here. And another one, key set. It will try to return only the set of keys here, whatever the keys we are having. And the same way, collection we are having values here. Okay, collection we are having values. And what are the other method we are having? So set internally it is trying to return entry. Now if you observe map.entry, map.entry is the one more interface we are having. Getting the point. So we'll try to discuss later how this particular map.entry it is going to work internally. But when we are calling this entry set, it will try to return the set of map.entry and internally key value pair. Getting the point? So inside this particular set of generic here, what we are passing is map.entry. Okay, map.entry. But you can see where this particular map.entry is defined. Inside this particular map interface, we define this particular map.entry. Here you can see interface entry. Getting the point? Interface entry. Whatever this particular map.entry we are discussing, this one only. Because this is the topmost interface and the entry is a nested interface. Okay, entry is a nested interface. Now you can see this is the one is a entry interface we are having. So if it is an interface, we need to identify the what are all the method we are having inside this particular entry. Okay, so first one is get key and get value and set value and equals method, hash code method, and this is the one of the static method we are having. Okay, and this is the one more static we are having, comparator. So this comparator is different and this comparator is different, and one more static method comparing by key. Okay, so equals method is different. This equals, getting the point? So this is the end point, like end break of this particular map.entry interface. Now what I will do, I will copy the few of the method. Few of the method I'm trying to copy. Getting the point? So this is the one of the important here, entry. Okay, entry will contain internally get key. Getting the point? Here we don't have any option to provide the value directly. We are going to get the key. So this particular key one by one in an order we are going to get. Same way we'll try to get this particular value. Get value. Now you can see the type key and value we are having, and one more method we are having, set value. So there is no set key, just we are calling the set value here. We are calling only set value, and other days we don't need to discuss about this particular equal and hash code method. Okay, equal and hash code method. So these are all the static method we are having. Comparator we are calling, and now you can see what we are doing internally. This is the method we are going to call comparing by key. It will try to return this particular. It will try to return. What is the return type here? This one. So k extends, so conditions we are having here. Getting the point? This is important. We need to understand. K extend comparable, and inside this particular comparable again we are having super.k. So this is the key and this is the value. Whatever the key we are going to provide here, the key value, so it should match this particular criteria. Getting the point? This particular criteria it should match here. So here this is only the condition for the key, and there is no value condition. And what we are going to get, this is the comparator we are going to get, return type, and name of the method comparing by key here we are having here. Okay, so static method. Now what we are doing internally, we are trying to call this particular c1.getKey compared to c2.getKey. The same comparative method it is calling internally. Whatever the comparative method we already identified in the previous example, the same one we are going to use here. Getting the point? And another, the method we are having k comma b. So now here value is extending, not the key. So key as same, but value we are having some condition inside the generic condition, and comparing by value. So this is the key method, and this is the value method. Now you can see get value dot compare to get value. Okay, and now if you say this is the another method comparing by key, here we are going to pass the comparator CMP, and the CMP it is comparing. The CMP internally it is comparing. Okay, explicit comparator we are going to provide for the third method, and fourth method now comparing by value inside this particular comparator. Okay, here comparing by key, we'll specify the custom comparator. Right, now these are all the 4 static method we are having to work on this particular comparator logic. The comparator one is very important here. The sorting related information we are using this particular comparator. Okay, now if you observe carefully, finally we are calling equals hash code method and get or default. Get or default. So now if you see, this is the one of the default method we are having here. So get or default here and all the default method. Now you can see for each is a one more default method. For each is the one more default method internally. It is trying to use the whatever the for each method we are having, the same for each is going to use. Okay, and all the default methods we are having. So we'll try to discuss this particular all the default method here. So there is no the abstract method. So far whatever we discuss here, so far whatever we discuss here, these are all the abstract methods only. Getting the point? So map will contain these are all the specific method, and entry will contain these are all the specific method, and remaining our abstract methods, sorry, remaining our default method as well as some of the static method here. Okay, now what you need to understand? First we need to understand the implementation classes. So map will implemented by the lot of interfaces, like a lot of the classes here. Now we'll see how it is implemented here. Now if you go to this particular map class, here only we can identify the implementation class section here. Here now you can see, so hash map, tree map, hash table. Okay, hash table will say what is the sorted map basically. Sorted map, if you observe, sorted map is a one more interface. Get in the way. Sorted map is a one more interface. Now internally, what you need to understand, it is internally extending from this particular map related section. Now you can see, now if you observe carefully, the sorted map, now it is extending this particular map here. And what we need to understand, the main important section, comparator. So we already identify this particular comparator, how it is going to work, but we'll see one more time. So submap here. Okay, submap. Now we need to understand this particular submap. It's like a sublist to subset as well as the substring whatever we discuss here, and head map as well as tail map. So we are going to have, these are all the four methods we are having inside this particular sorted map, recording this. And now another important section, first key, and here the last key we need to understand here. And same key set, whatever the key set we identify, same, the values method also same. From where we are getting it? From where we are getting? Here in the map here, because here now you can see key set, values and entry set. So these three again it is available inside this particular sorted map. Get in the van. Now this is important. Now these are all the specific method we are having inside this particular sorted map here. So what exactly the sorted map will do? Get in the van. This particular sorted map, it will give you the ascending order. Whenever we are discussing this particular comparator here, when we are having this particular comparator, we can easily understand here, it will try to provide sorting behavior. Okay, it will try to provide the sorting behavior. Now you can see, so map, and internally we are going to use the tree map is the implementation class. Sorted set basically the set related section class we are discussing, comparator, comparable, and some collection, because collection internally whenever we are using the return type here, by default, not this, here when we are trying to use this particular set, by default it is trying to extend from the collection only. Okay, so these are all the information we are having. So map class we are having, sorry, map here. So these are all the map related methods here, and entry related methods we are having, and sorted map related methods here. Okay, and another, the last interface we are having, navigable map. Now if you see this navigable map, internally it is extending from this particular sorted map. So what exactly the navigable map will contain? Same thing, the navigable set, what are the information we have. So the same method we'll have inside this particular navigable map, but only the differences here we are going to discuss with help of key value pair. So now you can see lower entry. Okay, lower entry, it is trying to return the map dot entry record, not the map records. So it is trying to return the map dot entry. What is contained here returns the key value mapping associated with the greatest key. Okay, here we are, what is the condition we are using? Greatest key, and strictly less than the given key. It is less than the value. So this is very important, we need to understand, less than, and whatever the lower key, and returns the greatest key strictly less than the given key, or if there is no such key, we are going to return null. We are going to return null if there is no such key here. So get in the pen. This is important here. And here, what we are doing here, so this particular param is going to take as a key, and it will return the entry. Get in the pen. And this particular method also, it's going to return tree if there is no such key here. It will also return null. Get in the pen. There is no such key. But here the return type map dot entry we are going to get, and here we are going to get only key. Get in the pen. This is important information we need to understand. So less than 0, and this is also will work on the less than 0. But what is the differences here? It will try to return the map dot entry record, and here it will try to return only key record. Okay, this is important. And now you can see map dot floor entry. Floor entry here, now you can see less than or equal to the given key. Less than or equal to this particular given key here. Get in the point. So this is, we need to understand very carefully how this particular floor key, it is going to work internally. Get in the point. Now finally, floor key. So this is the different. Say if you say some method they are trying to return the map dot entry, and some method they are trying to return the only key. And here now you can see it will return the greatest key less than or equals to the given key. Both are same, but only the difference here, it will return the key, and this method will return the map dot entry record. So this is easily we can understand here. These two methods will call inside the one of the method. Okay, inside this particular one of the method. Now same way we'll identify what are the method we are having. The ceiling entry here. Now you can see greater than or equal to the given key. Okay, so these are all the ceiling related method we need to understand. And map dot entry. Get in the pen. Map dot entry and only key. So these are all the difference method we are having, but two methods will do the same operations here, but only the difference is return type here. So hierarchy. Hierarchy. Now what you can understand here? Here greater than the given key. There is no or condition. Only greater than. There is no greater than or equal condition. So now if you see, this will take as a greater than or equal, but this particular section it will take only greater than. So these are all the different method we need to understand. This is also same, greater than, but here we are trying to return the key. Now you can see first entry. Getting the point? First entry. The first record we are going to get. So it's a simple name of the method itself. It is showing the information. What is the purpose of this? Same way, last entry. Last entry. And after this, pool first entry. So again we are having the differences. The pool first entry. Getting the point? So most of the codes are going to call internally the one by one method here, but the differences here, it is trying to remove the record and it will not return any records here. So this is only the pool related method we discussed in the last session also. It will try to remove the records. And what about this particular peak method? It will not remove the records here. It will try to, if the object is no longer available, it will return null here. Okay, now you can see, so return the key value mapping with associated with the least key in this map. Whatever it is going to map with the least, and here it is going to match with the greatest here. And the same way, it will match with the same list, but here it will try to return the null here. It will try to return the null if the map is empty, and here whatever the object we are trying to returning, the object is going to remove this particular pool related section. So same thing it is applicable, and for this particular last key also. Last key also. And we are discussing descending map. Getting the point? Now you can see this particular method, it will return the reverse order. Getting the point? It will try to return the reverse order. So this is the name of the method only. It is trying to show the descending order. And navigable key set. Navigable key set here. So it is trying to return the one of the collection related interface here. Only we'll try to load the set of keys here. We are going to load only this particular set of keys here. Okay, these are all the important method to work on this particular only keys. Only keys, and again now you can see descending key set. Only it will try to descend the key set here, not the values here. So this navigable map will contain lot of methods here, but internally it will work on the one by one. So one method internally, it will call another method here. Now you can see submap. Based on this particular value, it will try to create a submap. So now head map. Head map. We already discussed here. Somewhere we are having head map. Now you can see submap, head map, and tail map. Most of the methods, if you observe, the sorted set and the sorted map will contain the same similar method, but the differences here, it will try to load as a key value pair, but the sorted set will load as a only object. Only objects here. Getting the point? This is the differences we need to understand. Now head map we are having. Now we'll load the tail map. Now we are loading this particular tail map here. Now finally, so one more submap we are having, whatever we are going to pass. So this method is copied from the sorted map here. So these are all the method copied from the sorted map. Now I will copy here. Okay, I will copy this. Now you can see these are all the interfaces here. This is very important hierarchy we need to understand how this particular interfaces are implemented. Sorry. First one map, topmost map here, and simply it is trying to extend it from this particular sorted map, and the sorted map internally it is extended navigable map. Okay, these are all the simple example, but internally we are having one record, like one interface here, entry. Getting the point? Entry record. So there is no communication, just we created nested interface here. This is basically nested interface. There is no extending section here, but sorted map internally extending the map, and navigable map also it's trying to extending this particular map related section. Okay, only three interfaces we are having, like this particular three interfaces is going to take key value pair. But the collection section we are having lot of interfaces here, so it will try to perform the different operations one by one here. Okay, we'll see what are all the implementation classes we are having for this particular map, and later we'll discuss about this particular sorted map. Finally, we'll discuss about the one of the this particular navigable map here. Getting the point. This is important. We need to understand how this particular section is going to work. Okay, so now understand here. I'm going to write the implementation sections here for this particular map here. First, if you see the map itself, it's showing the hash map and a tree map. We'll discuss this particular hash map like a hash table later. First, we'll go for the hash map because most of the example already we identified this particular hash map, how it is implemented internally. Hash map demo. Okay, hash map demo I'm trying to create here, and this particular demo internally will create the hash map object here, and hash map is expecting key value. So the key I'm going to give as a string, and value I'm going to give as a double. Okay, so HS I'm trying to give, and we already identified the constructor because whenever we are trying to discuss about the hash set, we see the different constructors what we have here. Okay, now observe carefully. Default constructor, initial capacity constructor, and your map is extending internally. Like it's like a collection, same thing. We can pass one more map object here, and initial capacity, float load factor here. Get in the pen. 1, 2, 3, 4 constructors we are having inside this particular hash map. Now, if you say this hash map, first how it is implemented, we'll understand here. This is the default constructor. We are trying to providing the default load factor. So what is the default load factor we are having? 0.75 here. Okay, 0.75. Now where you can see, now here you can see this particular load factor will try to implement this one. So 0.75 here. It is a float value. Get in the pen. It is a float value. Now you can see what happening is this load factor used when non-specified constructor. So there is no explicit constructor. We are going to use this particular load factor information. Okay, what it will do basically, whenever 75% of this particular hash map is failed, it will try to create the new hash map here. This is the particular load factor is going to work internally. Now you can specify here default initial capacity. We are getting as a 16 here. We are get as a this particular 16 value. Now observe carefully. This is the hash map class we are having. Hash map internally extending abstract map here, and it is trying to implementing this particular map related section. So what are the abstract map is containing a protected the particular default constructor. So size they implemented here, and is empty they implemented, and contains value. Getting the point? Contains value and contains key, and so some of the method they implemented inside the one of the abstract map here. Getting the point? So try to read this how the each and every method is implemented. Okay, we'll see the first hash map. Later we'll come back to this particular abstract map here. Now go back to here. What we need to understand here regarding this particular hash map we created, HS dot which method we need to call? Put method. So the put method internally it will try to insert the data into the particular hash map. Okay, now I'm trying to give string. First one I'm trying to give as a key, and this particular value 12.01. Okay, 12.01 we are trying to store here. So we'll identify how this particular hash map is going to work internally. Hash map is going to work internally. we need to identify here. So we are trying to create the default constructor. What is the information will contain this default constructor? Nothing. So as of now, we did not insert any records here. Okay, so another important method, what we need to understand here. So put method, so it is trying to call the double method. Now finally, we'll move on to the put method. Now you can see, we discussed this particular put method already. First, we are generating this particular hash, and later we are trying to pass the key and the value we are passing, and other two sections. First parameter is a false, and second parameter we are trying to give as a true. So we'll identify how it is going to work internally. Okay, and we identify hash how it is going to generate here. Now if we observe key dot hash code basically we given as a key value, and whenever I'm trying to call this particular hash code, so which method it is going to call here? Hash code. So now we are inside the string class. Now we, like, why we are trying to move inside this particular string class here? Because what is the key? The type we are having as a string only. Now if you see, we are trying to generate the hash code here. By default it is 0. When it is 0, we are trying to check this particular condition and value dot length. So what is the value dot length so far what we are having here? Now 3. Now 3, because we given as a key characters like K, E, Y. So 3 characters we are having. Because of that, we are trying to load as a length 3. Now this condition is satisfying here. Once it is satisfied, it will go to this section. If this particular H is Latin, it will try to call this particular hash code. Otherwise, it will call this. So most of the cases, it will call this hash code here. We'll go to this. Now, what we are doing is we are trying to generating this, and the value we are trying to converting into the byte, because the string related section by default it will try to store into the byte array. Okay, we discussed already how it is going to work internally. Getting the point. Now what I'm doing here, I'm trying to multiply this. We are trying to generating the hash code. This is the logic we are going to use to generate the hash code here. Getting the point. How the hash code is generating based on this particular each and every value. The v value we are trying to use this particular hexadecimal here. Based on this particular hexadecimal, we are trying to add the value and we are trying to multiply. So the result we are trying to store into this particular h. Now come back to here. So which condition is satisfying here? H condition is satisfying. Whether this will satisfy or not. Now it is satisfying. So once it is satisfied, we can easily understand here what is the method. What is the method is going to run internally. Now if you see string Latin dot, this method we are calling hash code right now 0. What is the byte value we are having? 75, 69, 89. Okay, K, E, Y. Getting the point. Because of this, these are all the byte code values we are having internally. Now it will try to repeat 3 times here. So what we are doing basically here with help of this particular hexadecimal, we are trying to get as a 75. After 75, we are adding with this particular h. Right now it is 0. 75. Now it is multiplied with this particular 31. So finally, we are going to get the result as a 75. After this, now what we are doing here? After this, now what we are doing here we need to understand one more iteration. So 69. Now you can see 2, 3, 9 for the h value. So one more iteration we are doing here based on this particular like third record. So this is the final value 74303. What is the hash code we are getting? 74303. So this is the default hash code implementation inside this particular string class. Okay, if you are not interested in this, what we can do? You can override the hash code. You can write whatever the logic you want to generate here. Getting the point. What is the logic you want to write? You can write here. So this is very important information we need to understand how it is going to work. Okay, so finally we are generating the hash code. Now I'm coming back to the hash code method. The hash code 74303 it is returning, and finally we'll call the put value method. So we already discussed this particular put value, but one more time I'm trying to explaining it. So observe table right now it's 0. We did not insert any record. This is the first record. and the same here we are trying to check the first condition, because this is the first record. Definitely this if condition will satisfy. Definitely this particular if condition will satisfy. Okay, now what I'm doing here, I'm trying to call the resize method. So what exactly it is doing this? Now you can see internally it will call this particular big method logic here, but we'll see which condition is going to satisfying here. Old capacity 0 and old threshold 0. Okay, and here we are defining new capacity and new threshold. So both values are 0. Old capacity is greater than 0. So right now we are getting 0. So it will not satisfy. Now it will go to the else if section, and old threshold also will not satisfy. Now finally it will go to this particular else section. Now what we are doing is we are trying to find out the new capacity is the default capacity 16 we are going to get, and the threshold we are going to get something like this is the 0 and 75. We'll see the threshold and capacity. So capacity we identify, the threshold here 12. Okay, so capacity we are getting 16 and the threshold we are going to get as a 12. So once we get the 12 records, once we fill with this particular 12 record, it will try to create the new hash map internally. Okay, new threshold is not 0. It will not satisfy. We'll come back to this. We'll see what happening internally. Now if you see this, we are trying to creating the new node array. Getting the pen? Here we are trying to creating node array. Node array basically will contain multiple objects we are going to store, not one by one object. So what is a node type here? Node type. So these are all the node internally it contain like this. It contain like this. So this is important information we need to understand here. So node is containing, these are all the 4 values: hash code, key value, value, and next year. This is the node implementation. And whenever we are trying to write node array, whenever we are trying to write this particular node array, this particular object, it will try to store multiple objects here. Not only this particular 1 or 2, get in the point, it will try to store multiple objects here, but each type will contain the same. Each type will contain the first one is a hash code, and the second one is a key, and the third one is value, and it is a next node. If you are having any next node references, we are going to pass this particular next node here. Getting the point? This is very important information we need to understand here. This is very important information we need to understand how the node section is going to work internally, and where we are trying to create an object here. Here we are trying to create a new node here. And what is the new capacity? 16. How many the node object we can store? 16 objects. Okay, this is the default the capacity 0 to 15, 16 values we can store, and a new tab. So far new tab I am trying to set into the table. Every time we are going to use this particular table. Carefully observe, table is the class level variable. It will try to store all the node related values. Old tab, what is the old tab we are getting right now? Null. So this condition will not satisfy. Now it will go to the return tab. Okay, so simply it is trying to return the whatever the newly created object here. So this is the resize method is doing, and finally I'm trying to set into this particular tab, and after that I'm trying to load this particular length. Finally, what is the n value? 16. N value we are getting as a 16. After this, so we are checking here. So n minus 1 hash, based on this particular location, based on this particular condition, the first record is going to identify the which index location we want to store. Okay, which index location we want to store, the I value will identify here. Now if you see I value 14, in the 14 index location, the first value we are going to store. Getting the point? This logic is important. So n minus 1 and hash, n minus 1 and hash here. This particular section, now it is going to identify the where we are trying to store the particular record here. What is the record we are trying to store? This particular key and value. Now if you see, we are trying to creating the new node, and this particular new node we are passing the hash code, key, value and null. The null we are passing as a next reference. So as of now we don't have any next references here. So this is the new node method is going to call internally. What we are doing is simply we are creating new one node object. It is not a node array. It is a simple node object we are creating by passing this particular all the values. So here the next we are having null. Because of this it's going to pass as a null. It is a constructor basically. The new node constructor we are calling internally. Getting the point? This is very important section we need to understand. After creating this particular new node, we are trying to set into this particular tab. Right now we discuss this particular table. Okay, table how we created with help of this particular resize method. With help of this particular resize method, we created the new node array with help of this particular default capacity something like 16. Okay, so now I'm setting into the 14 index location. So mod count, and we are increasing the size, and we are increasing the size. Now if you see here, what is the condition we are checking? Threshold. So right now what is the threshold we are having? 12. Up to the 12 records are satisfied, we are going to call the same resize method. Whatever the resize method we called here. Getting the point? Resize basically what is doing? It is trying to create a new hash map here. New hash map, but hash map internally it is trying to store the object inside the node array, and each node will contain the hash code, key, value and next node information. Getting the point? This is the important information we need to understand here. So this section also important. Whenever the threshold is satisfied, the 12 records are satisfied, it will go for the one more bigger hash map creations here. So finally we are returning the null. Finally, we are returning this particular null here. So put method, simply it is trying to return as a null. Now it is a value it is trying to return basically. Okay. So this is all about the one of the put method we discussed here. So same way we'll try to identify lot of methods here. Same way we'll identify the lot of methods, how it is going to work. First I'm going to insert few records here. And here what we can understand, the second key I'm trying to store as a hash here. So it is a string we are trying to store something like 45.02 and hs dot put hash map we can store, and here I'm going to store as a 78 dot, sorry, only 1.03. Okay, 3 records are fine. And finally I will store as a system.out.println hs. Okay, this is important here. Now again I'm trying to restart this. Now we'll observe here how this section, because internally what we need to focus here, the simple example we need to focus here. The simple one we need to focus carefully how this section is going to work internally. What is the simple one? First we are going to check hash, and later we are going to compare with the key to identify the lower than object here. For storing here, just we identify based on this particular hash code, we'll identify the index location, and based on the index location the objects are going to store here. Okay, now we'll see loading purpose later, but now observe println we are calling. So if I'm going to print this, the hash is a key, okay, and this is the value. Map is the key, and this is the value, and key is also one key, and this is the value here. Getting the point? So how we are getting these objects here? This is important here. This is important. Based on this particular hash code, this order is going to create internally. Based on this particular hash code, the order is going to create. This is very important information we need to understand here. Now, so println method. Whenever we are calling the println method, we already identify the toString method. Now we'll go to the hash map, whether the toString is available here. So toString is available inside this particular hash map. Now we'll see how it is implemented. where it is implemented inside this particular node. Now what we are doing is key equals and value. Now you can see key hash equals value. Getting the way? So simply what we are doing is we are trying to call this particular toString. We are trying to call this particular toString here, and key we are passing, equals we are passing, and value we are passing here. But how the key and value we are setting here? The key and value we are setting whenever we are trying to create this particular node. Whenever we are trying to pass this particular node. Okay, this is important here. But we'll put a breakpoint here in the 294. We'll identify how this particular toString is going to work internally. Getting the point? This is one of the important example we need to understand. And this is the static node, what from where it is going to call this. From where it is going to call this. So it is not calling the particular toString here. Now we'll identify somewhere in the abstract map, do we have any toString? Yeah, here also we are having. We'll put a breakpoint here. We'll identify how this two iterator method is implemented internally. Now if you see, first what is the method we are calling here? Something like entry set. Once the entry set is called, and on top of this particular entry set, we are calling the one of the iterator method. Okay. To understand this particular iterator concept, first we need to understand the entry set method. So entry set basically what it will do, it will try to return the entry key value pair. Okay. Now we'll move on to this. I will run the same example one more time, just for understanding how this particular toString method is implemented. Now you can see abstract map is calling, and we need to understand this particular entry set. Now I'm trying to move on to inside this particular entry set here. So carefully observe what exactly it is doing here. Entry set we are having one reference. So right now it is null. Entry set right now it is null. Whenever it is null, what we are doing is we are calling this to insert this particular entry set. So we are creating an entry set object here. Okay, so it is creating the entry set object. After creating the entry set, we are calling iterator. So this is the entry set iterator it is calling. Okay, entry set iterator. So after this, we are calling entry iterator. Which object we are creating here? Entry iterator here. This is very important information we need to understand, because each and every iterator they are implemented like this. Entry iterator. So whenever this entry iterator is implemented, now if you see, so this is the entry iterator class. But whenever we are trying to discuss about the hash set, this particular example is called key iterator. Okay, right now we are calling this entry iterator, because entry will contain the one pair of record, key value pair of record. Okay, key iterator will contain only key, and value iterator will contain only values. But entry iterator will contain one pair record here, key and value. Now what I'm doing here, so this is the entry iterator is calling internally, and so there is no much logic here. Where it is there, above I hope, below. Okay, so anyway, we'll see the entry iterator how it is implemented, because we'll call the has next and next method. Now you can see has next method we are calling. How this has next method is going to executing internally. So this is the has next here. And what is the next right now? Next right now, hash equals to 45. Where this particular next value is stored here. Where this particular next value it is stored. This is important. Whenever we are calling this particular has iterator. But from where we call this has iterator? Getting the point? Where we are calling this particular has iterator. Now if we go to this, where are the classes are implemented? Because this is the one of the abstract class we are having. Let me see any below we are having. Yes, here only we are identifying. Whenever we are calling this particular entry iterator, it is trying to extending this particular has iterator. Okay, has iterator. So when this particular has iterated is called, at the time of this, the next value it is stored here. Get in the pen. Next time it is trying to store here. Now we'll see how this particular next value each time it will contain. So hash equals to 45. How I'm getting this hash equals to 45? Any idea? How this particular key equals to 45 value, like value I'm getting? Because the node internally it is trying to override the toString. The node also internally overriding the toString method. Because of that, we are getting the value structure like this. Okay, so just now we discussed the node section here. If you go to this is the toString. Okay, the line number 294, whatever we are having here, this particular line number 294, it is having key equals value. Because of this, here we are getting the format here. This is the format we are having. Okay, this is important information we need to understand. This is the one of the important information we need to understand here. After this particular has next, we are going to call the next method. Now you can see I dot next, and whenever I'm calling this particular I dot next here, from it is calling this where it is implemented this. We need to identify where it is implemented. Oh, we are having entry iterator inside the hash map. Okay, here only we are having. Now if you see this, I could not identify here. Here only we are having the next method. Directly we are calling the next node. Here we are calling the next node method. So we need to focus on this particular next node. This particular code is going to return the next value. Get in the pen. This particular section will return the next value. Now we are loading the next, and if it is not equals to null something, this the exceptions we are going to get. Otherwise, it will try to return the value here. Whatever the e value we are going to get, it will return. Okay, this is the next new node we need to understand here. I'm putting the breakpoint here, so for the next time we can easily understand how it is going to work. So you can see, because this is the entry, because this is the one of the entry interface. We already discussed here the entry interface method. Here, the entry interface contains these are all the methods: get key, get value, and set value. Now, if you see this, we are calling the get key method. We are calling this particular get key method. How it is implementing it? So inside this particular node, whenever we are calling this particular get key, so key it is returning. When we are calling this particular value, it is returning the value. Because the node, whatever the node we are creating, it is implementing from map.entry. Okay, it is implementing from map.entry interface here. The map.entry interface is containing three methods. First method, get key, get value, and set value. So these are all the three methods we are having here. These are all the three methods we are having. So these three methods are implemented internally inside the node class. Okay, this is we need to understand very carefully. So get key we are getting, same way we are going to get value, and we are checking if this particular key is equals to this, it will append this. Otherwise, we are going to store as a key. Okay, now as of now, if you observe this particular SP, one bracket we open, hash is a key, and we are appending with this particular equal, so that between we are getting an equal and value we are appending here. So this is the value. Now after the value, now you can see we are getting like this. Now what we will do, we'll try to, when we are trying to close this, so whenever we don't have a records at the time we are going to close. So right now we'll call the 559 we are calling. So we are getting comma and some space. We are getting comma and some space. Okay, to insert the one more record. Here we are going to insert one more record. Now if you'll see, so again I'm calling the next method. When I'm calling the next method internally, it is going to call this particular next node, and here you need to understand next here. Right now, so this is the 78 record we are going to get. 78.03, and the next node we are setting into the E. So this is the mod count, and E, if it is null, we are going to throw an exception. But we need to understand this if condition. This if condition is very important here. Now observe carefully. So current value 78. Okay, now the current value is modified with this particular 78, and later the table I'm trying to set into this particular T, and what you need to understand, E value I'm trying to set into this particular current, and this particular next I'm trying to set into this particular next, and this particular next if equals to null, and the T should not be null here. So this particular condition will satisfied. After this we will move on to the while here. So why we are moving here? Because right now the next is null here. The next is null because for this particular current, so 78, we don't have any next records. Whatever the 3 records we inserted here, these 3 records we inserted in a unique locations. There is no same index location. Okay, because of this, now it is time to returning like this. After this, now what you need to understand here? Get in the pen. After this, now what you need to understand here? Here we need to understand index. What is the index right now? 14, and T dot length. T dot length we are having 16, so it is satisfying. And next we are going to replace with this. So T is a array, and index in the 14 index location, whatever the value we are going to have, the particular value we are loading here. Get in the pen. The particular value we are loading. Now if you see this in the 14 index location, this is the value. Key equals to 12.01. Get in the pen. Key equals to 12.01. We are loading this, and we are trying to set into this particular next here. So this example, this 2 lines of code, it is doing lot of initializations and condition. First, the E we are trying to set into this particular current, and later after setting, now what we are doing is this value, the current, now it is trying to set into this particular next. No, so once we set this particular current, we are calling the next value. The next I'm trying to set into this particular next here, and whenever we are trying to set into this particular next, if it is equals to null, get in the pen. If it is equals to null, one condition will satisfy, and whatever the table we have, the table I'm trying to set into this particular T, and the T, it should not equals to null. It should not be null here. So now finally we are trying to set into the next as the key and something 12.01. Okay, finally we are trying to returning this particular E. So something like 78 related information we are trying to returning. Now if you see key value, okay, this is the second record also, it's completed. Finally we are returning the third record. Now you can see it is time to close. So finally what we are doing here, object.toString we are calling, and we are going to print this. Now you can see hash equals to 45, map is equals to 78, key equals to 12.01. But how we are getting this this particular braces here? This is important here. This braces inside this particular abstract map. Abstract map is providing this. Here we are opening and we are closing here. Okay, this is important information we need to understand regarding this particular hash map, how it is implemented internally. Any questions here? Anyone having any questions so far what we discuss here? Okay, if we don't have anything, now we are identified here how this particular put method is working, and how we identified the iterator method, how it is working internally. So finally, so we'll get the get method. Getting the point? We are calling get method. So what we need to pass here? Key we need to pass. For example, if I'm going to pass this particular map here, if I'm going to pass this particular map, how it is going to work internally, we need to identify first. The get method, how it is working internally, we need to identify first here. Now you can see we're trying to call this particular default constructor. We are inserting the value. Now I'm calling the get object by passing this particular key. So what is the key I'm passing? Map. Because the map record we inserted in the inside this particular hash map here. Now you can see now what we can understand here. First we are identifying the node here. So how we are identifying this particular node here? How we are identifying this particular node here? First we are again loading this particular hash code. What is the hash code of this particular key? The whatever the value we provided for this particular map, we need to identify the hash code. So this method we already identified. Internally it will call the string Latin method. It will return the hash code here. Okay, the hash code again we are passing into this particular get node. So to identify the get node here. So now if you see what is the hash code here, something like 77117. 77 and 117 is the hash code of this particular map key. Okay, and after this, now what we need to understand here, after the hash code, we need to identify the key. What is the key we are having? Map. So this is the key. Finally, what I'm doing here I'm going to provide the so table I'm trying to set into this particular tab. After that I'm checking the not equals to null condition and tab dot length and we are trying to set into this particular n and it should be greater than 0. After this we are trying to store the first value. Based on this particular condition, whatever the record we are going to have inside this particular tab, if it is not equals to null, this particular if condition will satisfy. Okay, so anyway the condition will satisfy here. Anyway, the first condition will satisfy. What is the first record we are having here? Something like map here. How we are getting this particular map? Here we need to understand here. Getting the point. So here using this particular n-1 and hash, we are trying to identifying the index location. Getting the point. Index location. Based on this particular hash code, we can easily identify the index location and we are trying to load this particular value here. Getting the point. This particular value we need to identify here. Now first record. The first map only we are checking here and we are checking the hash code and to this particular hash code and later we are trying to check this particular key. Later we are trying to check this particular key. If it is matching, we are returning the first. Otherwise we are checking this particular first dot next. Okay, first dot next we are going to match. So now anyway the first condition only it is satisfying it. Now we are trying to returning this. So this is the way of loading the object from this particular hash map. Getting the point. Now we identified this. So it is returning the node. From the node we are calling the value. So that it will try to return the value. And finally we are calling this particular iterator. Iterator we are calling. So now here only I am going to put a breakpoint. Sorry, like a println method to print this particular values here. Now you can see 78.03. How I am getting 78.03? Now if you go to this get method internally, here we are calling e dot get value. Here e dot value. So e dot value we are passing here. So when we are passing this e dot value, so simply we are returning the value. Now because of that we are trying to return in the generic type here v. The generic type also we are using the v. Okay, this is important information we need to understand regarding this particular get method. So any questions here? Any questions regarding this particular get method? Okay, I think so. We already familiar with this particular is empty method, something like so size method, clear method. Getting the point. So we don't need to discuss this particular section, but important information. So contains key, how this particular contains key is going to work internally. If we observe after loading this HS dot contains key, I'm passing it, and what is the contains key we can pass here? Getting the point. What is this particular contains key we can pass? Something like a map only I'm passing here. Getting the point. Map only I'm trying to pass. So we'll see what is the return type of this particular contains key. It is trying to return the boolean value. Now what we can understand, if the key is available, so it will try to return the true. Otherwise, it will try to return this particular false section. Getting the point. It will try to return the false section here. Now you can see I'm trying to make as a if condition. I'm trying to make as a if condition. If it is returned true, we'll print this particular simply true value. Simply, I'm trying to return this particular true value. Okay, so we'll put a breakpoint line number 13. We'll identify how the contains key. Okay, before going to discuss here, now observe carefully. What we are doing here, we are trying to load this particular get node. So just now only we identified this particular get node concept, how it is implemented internally. So what we can identify based on this particular hash code and key, we are trying to find out the node. Okay, so the node is available, we are checking the not equals to null. Otherwise, this particular get node, basically it will try to return the node object. If the node we are trying to return as a null, so it will return false, but other cases it will return true. Okay, simple section. So because we already identified the get node, so there is no much code to discuss here. We are generating the hash code and key, and we are checking this particular section based on this particular hash code. We are loading the object from this particular node array. If it is available, we are trying to set into this particular first. Otherwise, finally, we are returning this particular null. If any one of the condition is not satisfying, finally, we are returning the null, so that the node is not available. But in our case, whatever the map I provided, it is available. But this particular test, whenever I'm trying to provide this particular test, it is not available. Okay, we'll see this particular test, how it is implemented internally. Because map section we discussed just now, so we don't need to discuss one more time. Now again, I'm moving into the hash code here. So come back to the hash code, get node method. What is the hash code of this particular test here? 2603157. Okay, so this is the hash code of this particular test key. What is the key we provided? Test here. Now we'll identify here the test is available or not. It is not available. It is not available. Simply, it is trying to returning this null. Whenever it is returning null, what happens internally? Because this entire section is null. Now what we are checking? Not equals to null. Getting the point? This particular condition is not satisfying here. It is returning false here. It is returning false. So whenever it is returning false, this line is not going to print. This particular line is not going to print. So this is the contains key. Same way, we are going to discuss about the contains value also. The contains value also, it will be same. So HS dot contains value. If you try to provide the value, random value I'm providing, anyway, the random value, it is available or not, it is a different section. But what we are doing is, we are calling here from the table, from this particular table, something like a node array. I'm repeating this. I'm calling equals method. Here we are checking the value. If the value equals to this particular value, or we are calling this particular equals method. So if it is identify, return true, otherwise it will return false. Okay, if it is identify, it is returns true, otherwise it will return false. This is very important. For the value section, we don't need to check any node like a hash code and the value information. So directly we can check the value. How we are checking it? Because we are trying to load the all the nodes here. The tab will contain all the nodes information. Now the type we are having this particular node, and internally we are checking e not equals to null, and every time we are trying to check this particular e next value. Getting the point? And here we should not satisfy this particular not equals to null, and we are trying to check this particular e equals to e dot next here. Okay, and internally we are checking the conditions like this, and if the condition satisfied, we are going to get as a true, otherwise we'll get as a false. So simply I'm putting here breakpoint here. We'll go for this particular hash map. Now we'll run this. The contains key we are not checking, and we are checking the contains value. What is the value I'm providing? Something like 852.04. This method is no longer available inside this particular node array. But anyway, what we are doing is we are trying to check this. So tab here. Okay, tab will contain whatever the values we are having. The three records 12, 13, 14. In the 12, 13, 14 index location, the three records are inserted. Now it will try to repeat the 3 times here. Now you can see e dot equals to null. So here e value we are having, null we are getting. Why we are getting this particular null here? Getting the point. First record null. Getting the 0 record we are getting null. So first record also null. Second record also null. Now what happening internally? Whenever this particular condition satisfied, then only it will go to this. Otherwise, we'll keep on repeat loop here. So first time is not satisfying, second time not satisfying, third time not satisfying, fourth, fifth, sixth, 7, 8, and 9, 10, 11. So the 12 condition is satisfied here. So once the 12 condition is satisfied, what is the E? Something like hash we are getting 45.02. Now what we are doing is we are checking this E dot value. What is the E dot value? This 45.02. Now I am trying to set into this particular V. After this, we are equal to this particular value. We are doing this particular 2 steps here. First, we are initializing the value into V, and later I am trying to check in this particular value. Okay. So if it is not satisfying, we are going to check this particular condition. If it is satisfied, we are returning true. Otherwise, we are returning false. So it will keep on repeating. Now it is not satisfying. So one more condition. Now this is the last iteration. This is also not satisfying. Finally, coming back to the false. False it is returning, because whatever we are providing this particular 852, it is not available inside this particular hash map. Okay, this is the contains key method. So contains key we identified, and this is for the contains value here. And what are all the different methods we are having? So contains key, and we identify get method, put method. So remove method. What it will do, the remove method? The remove method basically, it will try to identify hash code dot remove is expecting object key. For example, if I'm trying to pass as a test here, this test object is not available, but we'll see what is the remove method is returning double. Whatever the key we are passing, the value it is returning. Whatever the key we are passing, for that particular key, whatever the value we are going to have, the value it is going to return here. Now observe carefully what we need to understand here. Now you can see I'm going to run this particular method in the debug mode. Now, so here we identified this. I put a breakpoint in the line number 15. So we're coming back to the remove method. Now we'll go to inside this particular remove method, how it is implemented. We are trying to converting into the value, string value. Why it is printing? So, okay. Okay, anyway, now if you see, okay, maybe it is wrong. So this is the value it is converting, I hope. Why we are calling this print? Okay, I did not save this. Sorry, I did not save this example. Because of that, it is trying to print on this particular println only. Now you can see remove method I'm calling. Now I'm moving inside the remove method. But what we are doing here, we are calling the remove node here. So we are calling this particular remove node after generating this particular hash code. After generating this particular hash code. Now you can see if the remove node equals to null, we are trying to returning the null. Otherwise, we'll try to return the e dot value. Getting the point? We are trying to return the e dot value. So here we are. What is the operator we are using? Ternary operator we are using. This is important information we need to understand very carefully. Now you can see. Now I'm trying to generate this particular hash code. The hash code is going to generate. After this, we are calling the remove node. And what is the hash code? So it is a 2603157. Just now we identify the hash code for this particular test test key. Okay, what is the value? Null we are passing. So match value we are going to make as a false, and movable we are making as a true. So same thing for the insert node, whatever the values we are having, same value we are passing here. And finally, so tab, we are checking this, and the same condition, whatever the condition we are using earlier, the same condition we are using here for this particular get contains key put method as well as the particular remove node. So every condition is same here. Now if this condition will fail, what we are doing here, simply will return false, null value. We are returning null. But if you see, based on this particular test here, based on this particular test, we are not going to identify the object inside this particular node array. So here we are trying to use this particular condition. It is a tab, basically node array. If record is available, it will return. Otherwise, it will return null value. Now you can see condition is not satisfying. Simply we are coming back to the null. So this is the main condition we are using. Instead of repeating multiple times whether the object is available or not, simply we are in the if condition itself only we are checking. Based on this particular key, the record is available or not. If it is not available, simply we are returning null. Simply we are returning null, and if it is null, we are going to return as a null. We are going to return as a null. The remove method, finally, it will return null. So what you are understanding is, if the object is no longer available, it is not moving inside the remove node method. For example, if I'm going to pass this particular map record will available inside this particular hash map. Now, for this record, it will condition will satisfy. After the satisfying the condition, now we'll identify the code, how it is implemented. So remove method, first we are calling the hash code, and later we are calling the remove method. Condition is satisfying it because the record is available in the p index location. So map, okay, what is the index we are having? 13. So this is the whatever the key we provided, the particular key now it is available in the 13 index location. Now it is available in the 13 index location. So what is the node we are having? This is the node. Map is equals to 78.03. After this, now I am checking this. I am checking this based on this particular value. We are trying to identify the node. Okay. Now if you see this, it is satisfying. Now we are identifying whatever the P we are having. Now I am trying to set into this particular node. So after this, what we are doing is we are checking node not equals to null, impact value. Impact value we are having false. Now it is satisfied true. After satisfied true, here we are going to check what is the value. The value null we are providing. Okay, value we are providing as a null. So we'll see whether this particular condition is satisfying or not. So this particular condition is satisfying, but for this particular AND operator, we have a lot of conditions. So either it should be matched or it should be matched this section. Okay, it should be matched. So this particular condition is satisfying it. Now what it will do? It is moving inside this. So instead of the tree node, it is not a tree node here. It is not a tree node. Now node equals to P. I think same. The node equals to P. So this particular section will satisfy, I hope. Get in the bend. So now it is satisfying. After this, whatever the node we are having right now, node this one. So map is equals to 78.03. So whenever I'm trying to call map.next, right now, what is the value we are having? Null, because we don't have a relation here. Map not next here, the map not, sorry, map. So here, node not next here. Now if I'm going to call here, node not next here, now you can see null we are getting. In the expression itself, it's trying to show the null here. Okay, so the null value, it is going to store in the 13 index location. Now what you understanding here? So in the 13 index location, whatever the map record we inserted here, the map record now it is replaced with the null. Getting the point? This is important information we need to understand here. After this, we are returning mod count plus plus, size we are decreasing, so we are calling the node. So this particular node, it is not a null. Finally, we are calling e dot value. The e dot value will return here. Getting the point? So this is the important information we need to understand regarding this particular remove method. Getting the point? Regarding this particular remove method. So any questions here? Any questions regarding this particular remove method? Okay. If you don't have any questions regarding this, now put all method one is a pending method. So we'll discuss the put all later. First we'll go to this particular key set. How this particular key set is working internally. Okay, this is the key set method. Key set basically it will try to return the set of keys. Right now, how many keys we are having? 3 keys. So map, hash, and key. This particular 3 records are going to return by this particular key set method. Now we'll identify how it is going to return this. Now we'll identify how it is going to return this particular values here. Getting the point? So this is one of the important information we need to understand. We'll see this particular debug information. So key set. So key set, if it is not null, we are inserting this. But here we need to understand this particular key set. Getting the point? Key set internally it is trying to extending this particular abstract set here. Getting the point? Internally it is extending this particular abstract set. So whenever it is extending by default, all the methods we are going to get. By default, all the methods we are going to get. But here, now if you see, it is not implemented anything. Now internally, size method, clear method, iterator method, contains method, and remove method. Getting the point? So these are all the methods here, it is implemented. Now observe carefully. So when we are calling this particular iterator, when we are calling this particular iterator, it will try to return the key iterator. The key iterator itself, it will give you the all the information. The key set is important here. Okay. Now we'll see how it is going to work internally. I'm calling this key set method. We'll observe how it is going to work internally. Okay. So we are removing this. Anyway, we are calling this particular key set. Right now key set is null. Once a key set is null, now what we are doing is one constructor we are calling. So what is the constructor we are calling? This constructor. Okay, default constructor. If we don't have any default constructor, it will try to call this particular class only. Now you can see it is calling the default constructor. So once it is called this particular key set object, we are going to get. Okay, hash key, hash and key we are getting. How we are getting this particular hash and key? How we are getting this particular hash and key? Now we need to debug this. Here, any toString method we are having? Right now we don't have any toString method. But how we are getting internally? It will call this iterator. If I'm going to print this new key iterator, so this particular next node, if I'm going to put a breakpoint here, you will understand here. You will understand this particular example. Okay, and observe, again I'm going to call this. Again I'm trying to call this particular same. This I'm trying to remove this. Observe, whenever we are coming back to the key set method, here I'm going to put a breakpoint. 1491. Now you can see it is calling. From where it is calling a iterator dot next. So entry iterator it is calling. From where it is calling this? It is calling entry iterator. Okay. Now you can see it is calling in toString method. So this is wrong basically. This is not we are expecting. This is calling from this. But what we are expecting, from here only it should call here. From here only it should call. So if I'm going to print this, let me remove this. So it is wrong here. From the println only it is calling this. But the key set internally we are trying to create a one key set object. Key set internally it generated. It is trying to creating this particular key iterator class. The key iterator internally it will call the next related information. So this is important. We need to understand basically. If I'm going to return set of strings, it is trying to return here. After this, we'll try to print this particular methods here. Whatever the keys we are going to have, we'll try to print. But observe, it is returning only two keys, hash as well as key. So hash as well as key. Why it is not returning the map? Map we are trying to removing line number 16 here. But finally, what we need to understand very carefully. So it is trying to this key set method. It is returning the key set object, and key set internally it is trying to return the key iterator object. Internally, the key iterator it will try to return the value. Those values are going to return when we are calling this particular key set. Now this is important. So this is the key iterator it is going to call. And if I'm going to call this whether, so I added the breakpoint here, we'll see. No, it's not calling. That is one, it is not calling it, but the implementation code is same. Anything where we are using the key set dot iterator. Okay, so I think we could not find out the proper debug code of this particular key set here, how we are getting this. But whatever the code I'm showing, the code is correct. Getting the point. This is the key set. So and another one we are having hs dot values here. Values method. So values method basically what is doing internally. Now if you go to this, all the values from where we are getting the values. So we are trying to make as this particular values inside the abstract map here. Okay. Back to here, we are trying to create the values. And here, what you need to understand here, it is going to call the value iterator. The value iterator internally, the same method it's calling, and on top of that, it is trying to call the value. So this will return the only values. Getting the point. But these three classes are implemented to work on the iterator related sections only. What are all the three classes we are having? First one is entry iterator, second one value iterator, third one key iterator. So these are all the three important classes we need to identify to get the specific records here. So to get the key iterator, we need to call the key iterator. If we want to get the value, we are going to call the value. If we want to get the entire record here, like the key and value pair, we'll call it as a entry. It's like a entry record will contain key and value. So these are the important methods we are having inside this particular hash map. Okay, so any questions here? Any questions regard the key set and values and the remove method? Okay, if we don't have anything, so I'm going to stop the session up to here. We'll continue evening. Like we'll try to discuss about the another important section here. Something we'll discuss about the put all method. After this, we'll discuss about this we already identified this particular get key related entry section, and we'll move on to the sorted map. Sorted map, once we completed, we'll move on to the navigable map. So the navigable map interface is the last interface. We'll discuss what are the implementation classes we are having. Okay, we'll continue the evening session, and we'll try to discuss about the remaining two interfaces, how it is implemented internally. Okay, so we'll see you in the evening session.